Alright, hello again. This is Jeff Scott, your instructor for 152-119, Learning to Program with JavaScript. In the previous lecture, we went over, well, where is it? We went over this program here of, we looked at how to do a coin flip program. We got it to work, but what I wanted to show you, I've shown you now and gotten it to work both under the JavaScript runner and under JSBin, but I want to show you it the way you would typically see it done. Alright, so I'm taking this file that we have right here, and what I'm going to do is I'm going to create a new file. This will be a new HTML file. So and I'm going to call this JavaScript external. And if you don't know why, hopefully you will in just a minute. The file itself, it's going to be very short. About 4 or 5 more lines. So I'm going to put an H1 tag in here, and it's going to say JavaScript example using external file. And then I'm going to come down and I'm going to put in a button. So input type equals button, value equals run program, on click equals main. And I forgot a line, but oops, I forgot a line, but I'll put it in just a second. Come on. That's the whole file except for one line. Now if I run this right now, I've got to save it, so I'm going to save it here. I'll put it in my H1 folder, and I'm going to call this external.html. Okay, you can see how the colors change. And if I run it right now, nothing's going to happen except it's going to show that, and it's going to have the button, but when I click it, nothing will happen. And the reason for that is I have to come in here, and I have to include that JavaScript file. So script, and then I have to say source equals coinflip.js, and then end my script tag. Alright, so you can see there's only a dozen lines in here, but notice when I run it now. How many coin flips? 1,000. There it is, there's our answer. Do you want to run the program again? Yes. 1,000. Okay, you can see it. I could keep doing this if I wanted to. So no. Boom, I'm done. The only thing I want to make sure is I do is, and I mentioned this before, what I should have done here, you want to run the program again, yes or no? I should have really defaulted it there to yes. Okay? So let's run that one more time from over here and see if hopefully I didn't make any mistakes when I did that. Let's run it 2,000 times. Alright. Now notice it says Y if we want to run it again, and I do. So let's run it 100 times. Okay, and that's enough. So the takeaway from this, what I want you to understand is this. I created, here's my source. Right there. And I don't know how to make that any bigger, but basically it's the same thing exactly that you see in here. Whoops. It's the same file as the one here. So I create my doc type. Alright. There's my beginning HTML tag. There's my ending HTML tag. there's my beginning head tag, my ending head tag, my beginning body, my beginning body tag, and my ending body tag. Inside of my head section, I've got my beginning and my ending title tags, and my beginning and my ending script tags. So I'm saying make this file that's called coinflip.js, make that file available to my program. And that's exactly what we're doing here. All right, so we add a button. The button says run program, and when you click the button, run main. What main? Run the main from this program right here. That's the way you really should be testing. So what I'll do is I'll make sure to put a copy of this file right here. Not this one, but this file right here. I'll put that out on the system. All right. Now, the other way that you could do it, and I don't want you to do it like this, but I'm going to save this again, and I'm going to save this instead of as external, I'm going to save this as internal. So again, I'm showing you this, but you should not do this. And I didn't want to call it internal.js. That was silly. I wanted to call it internal.html. So let me go and change that. And in fact, I don't even need this. I'm just going to get rid of the file. Okay, and let's grab this. We'll copy it. We'll paste it. And we'll call it internal. There. All right. So now I'm going to come in here and I'm going to open up internal. In the previous one, when we did this, you saw what was in there. All right, but now it looks just the same now, but we're going to change it. So there's the internal. Right now it looks exactly the same as our external. But what I'm going to do is I'm going to grab all of this code, every bit of it that you see, all starting in line 15 and going down through line 72. So all approximately 55 to 57 lines. Copy it to the clipboard. And now instead of this script tag like this, I'm going to put script, an opening tag, and a closing tag. Okay? And in between those, I'm going to go and paste in my entire program. Now I'm going to have to pretty it up a tad. So let me just bear with me for a second. And my size on here is pretty big right now, so that's why it's looking real goofy, so there it might get a little bit easier to read. It's the same exact program that I did earlier. Exact same program. Again, I'm just tabbing it over. Just about done, as you can see. All right. So now I've got the file contained right inside of my HTML file. So let's run that one. Now we're still going to need a button telling it to run the program. So that's still in there. But let's run in Chrome. There it is. I have to change that to internal, so let's do that first, because otherwise I might forget. So we'll change this to JavaScript using internal file. And I think up here we used external also, so we'll call this JavaScript internal. All right, we'll go in and we'll run this now. Now it says internal. Run it 1,000 times. Boom. Run it again. Yes. 25 or 22, 4, 5, 6, 8, whatever. You get the idea. So the bad way, so to speak, to run this kind of program is to come in here and inside of your HTML file, take your JavaScript and put it right inside of there. And that's considered a bad way because, again, that's obtrusive JavaScript. And obtrusive JavaScript means that I'm actually putting the JavaScript right inside of the HTML. You should have unobtrusive JavaScript, where the JavaScript's in one file and the HTML is in another file, like what we had here. Not there. Sorry, that's still internal. External, there we go. And that one, we said, look, our script is someplace else. And if we click on there, there's our script, but it's its own file. I guess we can't open it from here. I thought we could. All right. So my suggestion, what I'd like you to do for the homework is to create something like this. Create a separate HTML file and run that. All right. Now, I'm only going to take about 5 more minutes, and I want to quickly again go through all the lines of code in this program. All right. So I'm going to get rid of that, and I want to just concentrate on the JavaScript right now. These are comments, so they're totally, the compiler just skips those. That's fine. So let's just start here on line 15, and we'll go for these 55 or so lines. We've got one function in this program. It's called main. It begins here on line 15. It ends here on line 72. All right. Typically, your JavaScript programs will have more than one function, but just since this is our first assignment, I tried to keep it pretty simple. All right. This means that it's a constant. In other words, it's not going to be legal for me to change the value of min flips or max flips when the program's running. Now, JavaScript is much more liberal with constants than other languages, but I put that in there so you could see how you typically set up a constant. That means we expect you to put in at least 1 in there when we ask you how many flips you want, but no more than 1 million. As opposed to constants whose value never changes, these values here are variables. They can change. It's possible that we could set them once and set them and forget them, or it's possible that they could change many times as the program's running. All right, it's kind of, for lack of better words, it's sort of up to us as far as what we're doing. But notice the first variable there is num flips. Well, every time we run this, we could put a different number in there for how many times we wanted to flip. And this is the random number we're generating, so that's going to be ideally be between 1 and 10, but different every time. This is going to be a 0. When we divide that by 2 and check the remainder, that's going to be either 0 or 1. If it's 0, we're adding 1 to our number of tails. If it's a 1, we're adding 1 to our number of heads. This is our variable that allows us to continue running the program. We ask the user, do you want to run it again? But we pluck off just that first character, and if it's a y, we'll run it again. So we've initialized our constants. You must initialize constants when you declare them. And here we've declared and initialized all of our variables. All of our numeric variables are initialized to 0. Our variable, again, is just initialized to what's basically a blank. And first char is initialized to y. All right, then we're saying as long as that first character is y, meaning yes, I want to keep going. So we ask the user, how many times do you want to flip the coin? Remember, this is a simulation, so how many simulated times do you want to flip this coin? And then we check to make sure that what we put in there is between, it's numeric, and it's between 1 and 1 million. If it's not, we just ask them to do it again. So again, when we get down to line 42 here, that means whatever we put in there in line either up here was numeric and between 1 and 1 million, or this was, because otherwise we're going to just keep them stuck in a loop here. So then we say, well, count how many times we put in there for num flip. So if it's 1,000, this will go from 1 to 1,000, and it'll generate 1,000 random numbers between 1 and 10. For each of those numbers, it'll do the modulo, or divide them by 10 and check the remainder, which will be either 0, and if it is, we're going to add 1 to our tails, or it'll be 1, and if it is, we'll add 1 to our number of heads. Then we'll print out the total number of flips, which is the total number of tails plus the total number of heads. So num tails plus num heads is always going to equal to num flips. Then we ask the user one more time, would you like to run the program again? And then what we do in here is We ask them to enter yes or no, but they could enter virtually anything. All right, so since in here we're asking them to enter a Y or an N, we're grabbing just the first character. So we're saying go to character 0, location 0, which is the first character, convert it to uppercase, and then assign that value to first char. If that first char that we just put in there, if it's not equal to Y, so the first character we put in was not. So instead of yes, if we put in ness with an N, it would be an N, so you would just return. But if we did put in a Y, if that first character is a Y, then we set our number heads, our accumulators here, we set them back to 0 so we can run the program again and ask them how many times. Okay? Hopefully that helped. Now, last thing very quickly here, your homework. The first problem I'm going to have you do by yourselves. Write a Java program to input two random numbers. So you already know how to get a random number. I just showed you that. Between 1 and 100. So let's think about what you're going to have in here as far as variables. All right? So your variables. You're going to have a variable num1, or whatever you decide to call it. Another variable num2. And both of these are going to be set equal to, and you use the random number function. All right? Then we're going to have another variable that's called sum, another variable called difference, another variable called product, another variable called quotient, and finally another variable called remainder. So those are all of your variables. So set up those variables. What I've just shown you here and here is all the stuff that's in here. All right? You'll do the math. I've already shown you how to do the math here. So what? Sum is going to be equal to num1 plus num2. Diff will be equal to num1 minus num2. Product will be equal to num1 times num2, etc. All right? When you get all done, you'll format the quotient to 2 decimal places, because that's the only one that might have a decimal. Okay? Put this whole thing in a loop like we just did with while again, or while first char equal Y. So do a similar type of thing. All right, so that's the first program. Second one, let the user, again, write a program that lets the user enter a number again between 1 and 1 million. This time we're manually asking them, so with a prompt statement. We're not using a random number generator. And then print out whether or not, so for instance, if it said this year, if it was 2015 was the number that we put in, it would say 2015 is not a leap year. A leap year occurs every 4 years. However, if the year is divisible by 100, it must also be divisible by 400 to be a leap year. So the year 2100 will not be a leap year. 2200 will not be a leap year. 2300 will not be a leap year. None of them will be leap years because although each is divisible by 100, each is not divisible by 400. 2400 will be a leap year. All right? This is the coin flip that we just did. So you've got that. And finally, I gave everybody a handout of iteration 4 of the payroll program. I'm going to say this one more time. Do not, these are comments that I put into the program. Do not key in those comments. That's just going to waste a lot of your time. So those are comments. All this stuff in here that's comments. Don't key in any of this stuff. Please. These are all just comments. You don't have to type in any of that stuff. Just key in the actual code that I gave you. All right, and let's see if I've got that here. So in other words, this is payroll iteration 4. So what I'm saying is, if we look at the whole thing, it is 216 lines long. But notice the first 106, so almost 50% of the program are comments. Please do not key in any of that stuff. All right, start here on line 106, create those variables, or 107, and then put the code in there. Okay? This is how we're getting introduced to writing different functions in our program. That's really about all I have to say. As always, if you have questions, concerns, email me at jscott@blackhawk.edu. In addition, we have 2 lab assistants who are more than willing to help you with this. The lab assistant for the class is John Wanda, JWANDA @blackhawk.edu. And in addition, there's Mike Wagman, MWAGMAN @blackhawk.edu. John and Mike are here all day Friday for lab for students. It's an open lab. John is here from 8 till 1. Mike is here from 12 to 5. They're always looking for people to help. As always, please let me know if you have any questions or concerns. Thanks for listening.